Thanks for the opportunity to speak. Yeah, I'm coming from another facility. It's not part of MagLab's umbrella, but we do a lot of the same things. We're a user facility. So let me talk about what we're doing for FAIR data at the NCNR. I'm an instrument scientist there doing reflectometry some of the time. All right, so this is our facility. It's a neutron beam user facility, mostly focused on materials research of one type or another. There's 22 scattering instruments and then some other things for imaging and analytical chemistry, sort of measuring concentrations of things directly with prompt gamma and that sort of thing. And in a typical year, and the last 2 years are not typical, so we're going to present some statistics from 2019. We have hundreds of beam time proposals and thousands of users, and we serve a lot of institutions, universities, corporations, et cetera. And we're hoping to get back there soon. It'd be nice to get back to normal. And within the NCNR, we have the Center for High Resolution Neutron Scattering, which is a CHURNS grant, which supports 5 instruments directly, some of our highest profile instruments at the NCNR. And those are listed here. And they had 266 proposals just on those instruments in 2019. And in addition, CHURNS provides support for the NCNR proposal system, which is the heart of our user program. That's sort of where everything gets started and where we manage a lot of things. And then very recently kicked off a non-equilibrium science initiative. This was a new initiative to support event mode data operations, that sort of thing. We're a reactor facility, so we haven't done a lot of that up to this point, but we're starting to ramp up, and that'll be something that we are going to support fully by about 2024. There's going to be a lot of development between now and then. And then more germane to this workshop is that in fiscal 2021, we began sort of a FAIR data initiative. I'm going to talk about that. So one interesting historical oddity about the NCNR is that for decades now, the raw data, every tiny bit of data that's recorded on the instruments by default is open and is available on our web server, and has been since the earliest one I could find was from February of 1989. And then there have been files continuously written since then, and we're up to 4,400,000 some, about 1.2 terabytes. And that number is misleading. If you divide that out, you get a few hundred kilobytes per file. Until about 4 years ago, I think the total size of the repository was a few hundred megabytes, and now it's 1.2 terabytes. So we're starting to switch to the newer, richer data files. We're using HDF5 on all of our new instrumentation exclusively. Well, I mean, we're also going to support column format. On a lot of instruments, we're writing both so that users have can use whichever one they find the most convenient. But the data of record is going to be HDF5, and there's a link to the root of our data repository right here. And then this is just an excerpt from our data management plan. And then what I didn't include in here is the fact that you can opt out. Anybody can push the defer button when they start an experiment, and that makes their data not visible for 18 months. It turns out that almost nobody does this. And part of the reason for that is all the other stuff that I'm going to show you is that if you don't do that, you get access to a lot more good stuff. So I think we only get a handful out of all those proposals and experiments that are done. We get less than 6, I think, per year that choose to defer and not publish their data right away. So up to 2020, before we began the FAIR Data Initiative, we already had some commitment as a facility to open data. It's been something that we've been working towards. We had, as I said, open raw data. There was some search capability available, but it was very limited. You could search by file date, name, or description. And we've had this interesting feature, and a lot of these features got born out of just making things easier for the users who come. As many of you are aware, as a user facility, people come and spend a very intense short period at our facility, and they want to have access to their data at all times. So in 2008, before I got started there, or just after I got started, but I'm not the one who developed it at first, was the live instrument data. So this is a web page that just sort of streams. It rotates through all the instruments and shows you the live data. It does a plot for every instrument as it goes through. And people love to watch this in our lunchroom where all the users congregate. It's just on the big TV there, and it rotates through all the instruments. And then a more recent initiative was online data reductions. This is something that I was heavily involved in starting before 2017, but in 2017, we switched over and all the reflectometry instruments started using online data reduction. So the data, no longer would they download a program to do their data processing to get it into physics units so they could fit it later on. The intermediate step where it was reduced from instrument coordinates and into sort of physics units, that was all done. That's all done online now. That's done through a web interface, and I'll show that later. And then we started building up sort of web-based data viewers. There's a column format plotting program that lets you do sort of multi-XY plots on the column data that's stored on our web server. So, and this is enabled by the fact that all of our data is open, so you can just click on data files and view them this way. And the other one that actually spent a lot of time on is an HDF5 web-based viewer. So this is, there's no server component to this. It just reads HDF files in the web browser and displays them to you, does graphing and that sort of thing. And I'll demonstrate that later too. So this is a visualization of our data life and metadata lifecycle, up to before the beginning of the fair data sprint. It all starts with the proposal and then goes through, you start and you plan your experiment. And this is when you show up at the facility in the middle part there. I don't know if anybody can see my mouse or not, but when you show up at the experiment / nice part, that's when you're sitting down at the instrument. And so the dark blue line on the left there from proposal to experiment represents the metadata that we're able to pull directly from our proposal system into the instrument control software. And that includes usernames, experiment title, and the unique ID for that experiment. And that gets propagated into each data file. So a record of that experiment, then that information gets stored. So right now we're running everything through the data files because that's sort of our main output right now. Everything goes into the data file, all the measurement stuff goes into the data file, and then they get popped into our public data repo. So everything yellow, and there'll be more of these in the future. Everything yellow is a public service or repository. So this is the one I was talking about before, where all of our data is available. And then users immediately grab data out of there and start doing their processing on it. They do reduction to get into physics units, and then they do fitting and then publication. So this is, it's a very straightforward flow chart. It's always this easy, right, when you do a publication. And then during an unplanned reactor outage of 2021, there were some reasons that we had to turn off the reactor, and unfortunately, and they're working very hard to get it back going again. But during that time, NSF asked us to refocus some of our resources, mostly human resources, so this is people, on accelerating our standing with respect to fair data. So we're doing, this is sort of 5 tasks. There are more than this, but these are some of the 5 high-level tasks. Doing ORCID integration across our data system, creating a DOI per experiment, searching data by metadata, capturing process metadata, and more traceable data reduction workflows. So these are some of the main tasks that we're going to be working on. So starting with the ORCID integration, and this jumps ahead and backward a little bit because I'm mentioning some of the other tasks within this task. But in the proposal system, we're going to enable a federated login. And I think this will be a strong incentive for the users. Every time we do something, we want to make it so that it makes the users' lives better, so they don't feel like they're doing something onerous to participate. And if they don't have to remember yet another password, if they only have their ORC ID and that's what they can use to log into the proposal system, then things are a little easier. One less password to remember. That's the benefit here. And then on our side, we get user disambiguation. In a user facility where you have hundreds and hundreds of users, sometimes a few of them have the same name, or people re-register with different email addresses or this kind of thing. And we're hoping that people will just have one ORC ID. And then this will allow us to identify people. And then, as everyone here is also aware, ORC IDs have other benefits for associating these unique people with publications downstream. And that's something that we want to do as a facility too. We like to keep track of how many publications are coming out of the data that we're creating. At the instrument control station, the ORC IDs will get pulled from the proposal along the metadata that's already being pulled down there. And then these will get used when we create a DOI record for each experiment, which I'll discuss a little bit later. And in the future, there's more uses for this ORC ID that's being, if it's tightly integrated, we can use it for a few other things. Maybe we'll use it for logging in for compute resources. We want to be able to allow users, when we get to event mode data, we want them to be able to, pre-process their data before. We don't want to ship terabytes of data over the network. So we want to allow them to log in and specify a few reduction commands and then extract, less than gigabytes of data, hopefully at the end of it. So we want that's something we're thinking about for the future. The people that are contributing to this, I want to point out specifically Steve Pfeiffer. He's one of the lead developer, or he's the lead developer for our instrument control software, and he is actually the project manager that's organizing a lot of the efforts on this fair sprint. And so I really want to thank him for everything he's done for that. And then his team that's doing the instrument control software is also handling a lot of the workload, because much of what happens at the facility happens when you sit down at the instrument and do the instrument control. And so a lot of this functionality is being built in to the instrument control software. And then a lot of the ORCID identity stuff is happening in our center office, and we have someone who's working we have one main developer for our proposal system, and he's working on that. And then we've had a lot of input from the scientific staff, and they've provided a lot of feedback on what would be useful to them and what would be useful to users, and sort of what we should be looking for when we're trying to work out how to add sample metadata and taxonomies and that kind of thing. So for making the data more citable, we want to create a DOI per experiment. We're going to do this using a repository that lives at NIST. This is the data.nist.gov, and we're working with them to establish an API handshake. So we're working on our end, they're working on their end. We don't have this set up yet, but this is going to happen, I think, within this next year timeframe. And then this will create a DOI at the beginning of every new experiment. So you come at the beginning of your proposal, you get your proposal is awarded time, you show up, you start your experiment, and then a DOI is created. So this contains user information, title description, activity dates, and some links to some of the other online resources that we have. It doesn't contain everything, but it contains all the stuff that's facility related and automatically generated at the start of an experiment. And then we want to do more searchable metadata. So we're adding some abilities within the instrument control software to define sample metadata. So we're going to have drop-down menus for taxonomies and this kind of thing. And then when measurements are taken, when you stamp out a data file, the sample metadata that's associated with the sample that's in the beam gets added to that data file, and also gets added to our database that we're going to create. We're going to stand up another database that's going to allow you to search metadata to find files that are associated with samples and metadata. So we're going to do that in-house. And then when that's done, we'll have a public search API. So this will help with machine learning and AI. They can comb through and do, this will be a way to search for keywords and metadata and look for ranges of temperatures and whatever sort of things you want. And then of course, we'll also bolt on a really nice, pretty human interface for doing searches if you want to find stuff. We want to work on capturing process metadata. This is already something that we mostly do, but we would just want to make sure that all the I's are dotted and T's are crossed, and make sure that at every step when we're doing our measurements that we're capturing the measurement intent and sample environment, and everything is being properly recorded and tagged in a way where it'll be easy to extract this later on for search. And then traceable data workflow. So after the data is already taken, we do the processing, and we want to make sure that at the reduction step that we have a variety of different instruments and a variety of different data reduction systems. And for each one of those, we want to make sure that it's possible at least to record all of your steps and then give that to the users so that they can publish it with their data and say, this is how I made my data. And in many cases, we're going to support where you could just reload that entire recipe into the data reduction system and rerun the whole reduction and maybe change your parameters and see how it would affect your reduced data. So that's something we're aiming for. Mm-hmm. So this is where we hope to be afterwards. So our little diagram has gotten a lot more complicated. So you still started the proposal, but now we're adding more metadata to it. And based on things that I was listening to here with Craig Brown, who's the churns manager who's overseeing all of this, we were talking about, people had mentioned getting grant proposal IDs and that kind of thing. And that's another piece of metadata that we think would be useful to add at the proposal stage. So if you put your grant ID here, pulling that in with the ORC IDs and feeding that into all these everywhere else that there's a blue arrow here, and that would be a great thing to add to the record that we're creating. And that's directly from having listened to people here. So I really appreciate that. And then we want to start letting people put sample metadata in at the experiment planning stage. So we're going to support spreadsheet import basically. Once you sit down at the instrument, you should be able to import sample metadata as a spreadsheet and then edit it there. And I showed that little screen really quickly, but then the sample metadata gets propagated into the data file. But then we're also going to add the little white and blue table there on the right there. And that's an intermediate artifact. I love intermediate artifacts. This is another spreadsheet that will get created at the end of the experiment where it'll link every data file to which sample was in the beam and what the sample metadata is. Users can download this. It'll be stored right next to the data in our data repository, and users can download it and put it in their own data record if they're publishing a paper and their supplemental data, wherever they want. And we're going to encourage people to take that and plop it right into a general data repository like OSF.io. And we're mostly thinking about general data repositories because we are a generalist facility. So it's hard for us to focus on individual specific repositories because a lot of different types of systems are investigated at the NCNR. People show up with samples that represents science of a lot of different types. So we measure specific, material properties, but then this is attached to different chemistry, physics, soft matter. I mean, there's so many things that happen, and it's really exciting, actually, all the different types of science that happen there. But it means that we have to attack it in sort of a general way. So we're going to encourage and teach people how to use OSF.io, and based on stuff I've seen here, maybe we could look towards more tight integration and provide tools for people to upload directly to OSF.io or something like that. And then we're also going to maintain our own metadata database over here on the right, and that's going to be the source of our search, our metadata search. So we're looking at MongoDB or something along those lines that just allows us to put arbitrary metadata. Probably not too much structure in it. I think I want to keep it down to key value pairs, although people have talked about arrays and this sort of thing. So we're trying to support everything that's being asked for from the instrument scientists. And then later on, when you get to the publication part, then you can link with your DOIs, and in your publication, you can create all the links between these things, and you can cross-link between the different data repositories also, so put DOIs from each and the other. And then we'll end up with all of these public resources, and we're going to put an API in front of each of them so that machines can come and talk to them and get stuff out of them, and other systems can interoperate with them. And then there'll be a nice web search on the front end, as I mentioned before. And then because of all of our commitment in the past to fair data and things we're looking forward to in the future, there's some nice things that you can do once you have open data. You can do this online data reduction. I'm actually going to do a tiny, very, very quick demo of this. You can add more information to your data repository pages, and you can have a bunch of public data viewers. So let me go back to Reductus. So let me exit full screen. Can you still see the screen? Okay. So this is our online data reduction. So this is our data repository on the left. You said it says NCNR data at the top, and then it has all these folders down below there. I'm going to reload an existing measurement that we did. Let's see, template one. So the spaghetti at the bottom there is the steps that are being done on the data. So this is a loader, and then go through some different steps: subtract background, divide, select out some XYs, and when you get close to the end, you can convert it into QX, and you can look at your data there. So this is how the users reduce their data for reflectometry. They just go to the web page. All of our data is open, so you don't have to log in or anything like that. And then this hierarchical tree for working with your data is populated from the metadata that's inside the files. So it just goes through there and finds it all. And you can browse through all the different folder levels and just find your stuff. There's other ways to actually find the data. You can get a direct link that takes you to this page and opens up a specific folder, and that's what we're going to put into the DOI record. So you'll just jump right to this page, and it'll open up the folder that has your data in it. So that's sort of a quick jump that we're going to do. And then on each data file, there's also this little info link. So you can click on that, and that takes you to our HDF viewer for that file. So if you want to inspect what's inside each file, this is let's see, let's look at the data. So there's X and Y. So this is the HDF viewer that I was talking about. So this is reading the HDF file in the browser here and letting you look through the tree and look at all of the metadata and that sort of thing and browse through it. You can look at whichever ones you want. Just click on any of these. So that's something that we implemented just because there was a barrier to entry for HDF files. Everybody said these are great, but I can't actually see what's inside them. So the easiest thing that we could think of is just have a web page. You just go there and you can just look at them. And at the bottom of the page, there's load local files. So if you have HDF files, you can try this out yourself. If you go to this web page, you can load up any HDF file that you want. I downloaded one from the National Weather Service, and there's some data inside there. I think those are clouds or something like that. But yeah, so that's an extremely quick demo of what we can do with our open data that I think, providing these incentives to users is really how we're hoping to get people on board, is just make everything work a lot better if you stay within the open data system. So that's the end of my talk. Thanks.